This is Natural Selection Lesson 3.3, Activity 2, Part 2. You should have just completed the write and share routine. If you haven't done that yet, make sure you do that before you watch this video. So let's talk about this. So if you did write and share routine number 1, you're trying to figure out if mutations affect which trait was the most common at time 3. So the first thing we should do is look at what trait is the most common, and we can see here that the highest distribution is trait 5 of cold resistance. So this is the most common trait at time 3. So can mutations explain this, or did they affect this? So we know that a mutation means that a trait shows up that did not exist in the initial population. So if we look at the initial population here, trait 1 and trait 6 are the only ones that don't exist. So trait 5 is the one that's the most common, but that existed in the initial population. So mutations didn't affect this trait. What can explain this is that the environment changed to colder, and so then trait 5 became an adaptive trait, and so it became more common over time because an adaptive trait makes an organism live longer and they will reproduce more, and then their population will increase. So mutations did not affect this one uh, for student number 1. So if we look at student number 2, again, same question. So if we look at population at time 3, we can see that number 6 is the most common. And if you look at the initial population, 6 is not part of it. So you can see that 6 showed up here, which means that a mutation occurred. And then sometime later, the mutation becomes the highest distribution of that trait. So that means that the mutation did affect which trait was the most common at time 3. So if you look at student 3, again, time 3, number 2 is the most common trait. And then if you look at the initial population, number 2 is in the initial population. And you can see that number 6 showed up. So this was a mutation, but it didn't really change from time 2 to time 3. So this is different than in student number 2, where the mutation from time 2 to time 3 ended up becoming a higher distribution. But in student number 3, that mutation didn't change. And you can see that really nothing changed, except now we have this trait of color level 6, and it still stays the same. So in order to answer this question of whether mutations affected the trait that's the most common in time 3, we have to answer this in 2 parts. So first, we need to decide whether a mutation occurred, and that means that there's a trait showing up that didn't exist in the initial population. And then we need to decide whether that trait became more common in the population. And so we know this is our investigation question, is what determines whether a new trait will become more common in the population. And a trait will become more common in the population if it is adaptive. And that is our key concept for this lesson. So a new trait will only become more common in a population if it is adaptive. So again, we can see that if we look at student number 2 and student number 3. This trait didn't exist in the initial population, but then at time 2 it shows up. So there was a mutation that occurred, and then from time 2 to time 3, the distribution of trait 6 increased. So this trait became more common. But in student number 3, in the initial population, there wasn't a trait level of 6, but then it showed up at time 2, so that means there was a mutation that occurred. But then from time 2 to time 3, it did not become more common. So the mutation in student 3 did not become more common, and the mutation in student 2 did become more common. So we know, applying previous knowledge from our other lessons, that traits that are adaptive are more likely to survive. So if a trait becomes more common in a population, that means that that is an adaptive trait and they're more likely to survive. So that is the key concept, is that a new trait will only become more common in a population as adaptive. So in student number 2, trait level 6 was adaptive. And this makes sense because the water got colder, and if you have a high level of cold resistance, you're more likely to survive in that cold environment. So this makes sense. Student number 2, this trait level was not adaptive. So the color of being brown versus yellow did not increase your chances to survive, and so nothing changed. It just stayed the same. So mutations can produce adaptive or non-adaptive traits, but the traits mutations produce only become more common in a population if they are adaptive to a particular environment. Make sure that you've turned this into Canvas when you're done, and then also make sure that you go back to Canvas and mark, actually you're submitting it so that you don't have to mark it as done. So there's nothing to hand in Amplify because you're doing your work in Notability. So turn in your write and share routine into Canvas and then move on to the next lesson.